Hi everyone, welcome back to the YouTube channel. So today we have another project. So where do we start? So there's traffic and I'm going up and down the road here, so just ignore it. So about 3 weeks ago my friend came to me and asked me could I repair this machine at the bottom here. So basically what it is a rotary table for welding on, to create nice, neat and strong welds. So I'll wait till that car passes there. So basically, when my friend turned this machine on, it went bang, and smoke started coming out of the PCB board inside this box. So what I done is I took it home and found out the fault and repaired the PCB board. So basically, we have a bunch of plugs at the back of the welder. So these plugs basically shorted out the PCB board. And it all started from there. So after that was completed, the plugs were removed. So basically these plugs are of an old cheap sort of, well, quality, made in China I'd say, very cheap. So I removed the three of them. One of them is for the welder connections, one of them is for the motor, and one of them is for the foot controls. So there's a high current DC supply going to the motor here, or sorry, high voltage, so 200 volts, and that's it. So then when I fixed the machine, I repaired the machine, he asked me can I build an attachment for this machine that creates a nice weld pattern, sort of like a weld bead rather than having a stringer bead around the workpiece. So what I'm going to do now is I'm going to give a wee demonstration of placing this part on that my friend welds. So what do you see? Or that my friend assembles. So we have this pipe, we have these flanges. So he's looking to create a nice neat weld around both flanges, nice tight seal. So where do I put this on? Okay, so she's on there now. So basically, before I made this attachment that's on this machine now, there used to be this attachment. So this attachment was fixed. So basically the weld torch always sat in the same position and the workpiece spun 360 degrees to weld it. So if I turn this on now, so basically we have this table set now. Well, I have it set because I'm going to do a demonstration in a minute to weld this piece. So it's taken 2 minutes to turn this 6-inch pipe to weld it. I'm going to demo welding a stringer bead, and then I'm going to, well, just the weld torch sitting there not moving a straight line around obviously the pipe. Then I'm going to demo this yoke moving. I'll turn it on here now, this too. So you can see there, you might see it there, but I'm going to do a close up now anyway. So this is all made, handmade, using bicycle parts and parts out of a wiper motor out of a Honda Accord. We also have bicycle seat parts, we have bicycle hub parts where the pedals connect on. We have the wiper arms all modified and turned down the lathe to fit this. So what I'm going to do now is I'm going to bring the camera up and do a full walk around of it, and I hope you enjoy, and it's really interesting, and the welds come out. Oh sorry, I forgot to mention. So I have set up an output for this machine that starts the welder, so basically it triggers the torch, the transformer or the inverter. So this welder was first connected up to a transformer, SAP 250 amp welder I think. My welder's an inverter, so it's much more smoother, but I have yet to do any practice runs on this, so hopefully it turns out well from the start. I only have one workpiece. Hold on. Sorry, I have one workpiece. I've only got three flanges, so what I'm going to do is I'm going to start and do a test stringer bead on this one that has one flange with the torch not moving. So let's stop there now, 2 minutes. We have this fixed unit that holds the weld torch, but I won't be using that. I will be using my clamp, and my clamp then will be turned. The machine will be, my mechanism that I've made will be turned off to do the stringer bead, the one straight line on this part. Then I will do well, the weave effect. So basically, it'll be like a ladder weave. So the torch will be moving on a ladder, sort of like a triangle weave. Up, there's obviously one pattern, but the pattern can be altered by adjusting the speed, the voltage of this motor. Um, the weld width can be altered with a wee slot at the back here. I will show that in a wee minute. The weld height can be adjusted by making the weld width wider, sorry, the weld bead wider for the weave, and also by the weld height can be reduced by increasing the speed of the turntable. So a lot talked about there, so what I'm going to do now is going to bring the camera up and do a full walk around of the unit. I'll start with this unit that was purchased, the unit that blew up, brand new unit that blew up when turned on. So as I say, it's now repaired. I repaired it first before I started building this device at the top. At the end of this video there will be loads of photos of manufacturing the parts and assembling the whole unit. So it's quite interesting, so I'm going to bring the camera up now and do a full walk around, and I hope you enjoy. Okay, so starting with this unit at the bottom, the rotary table, the rotary machine. So here, I'm just going to get these out of the way first. So I mentioned there in the intro about these connections. So these connections have a resin between obviously the negative and positive of the pins and or the terminals. So this resin, obviously when you put a high voltage through it, the voltage, there's a wee bit of a sort of like a high resistance there, so they're basically shorting, they shorted the PCB board out, and here the power supply. So this power supply is obviously variable, and there's also a timer here at the bottom, but this power supply had to be repaired. There's a high current resistor blowing up near the voltage regulator and the actual unit itself. So what do we see now? So starting with these connections, so you can see here this welder connection is just basically a contact, so it's a relay, basically a switch. So once I hit the start button on this machine, it closes these two terminals and creates a short circuit as such. So basically that triggers the welders for starting. So I have a lead made, a harness that goes straight to the welder, and I will demo that when we're welding. So first things first, I'm doing this video outside for the clearness of daylight. So we have this handle. I'll just give you a wee intro on what this machine does. So basically I could screw and set the workpiece wherever I want it. So basically if I wanted the torch aimed down here now, it basically the weld's not falling away at the side, and also it gives you, what do I move this unit back? So if I start this shot now, so you can see it's turning slow. If I go like this, so this handle is what releases the part or the workpiece to be welded. You have these jaws that open out quite wide. I never actually tried it. What you see in here is just oil, because I cleaned this yacht before I started the video here with penetrating oil. So they open out to about maybe 8 inches. Sorry, 6 maybe. I don't want to go much further because they'll fall out. I'd say about 7 inch, maybe 7 inch. Obviously you can put something on here and outside this too. At maybe 12 inch or more. They hold it flat to the surface. So any position, I can screw that right down to perpendicular to the bench. What do you see? So there now, and then I can put the torch into the unit that I've made. We're not going to go on that yet, but we're going to keep at this in a minute. So we have this DC motor that's rated 200 volts. Probably a low voltage going through it when I have it turning set at the speed it's going at now. There's a gearbox on here, so the motor's going actually harder than obviously this table itself. So we're going to bring this back up now and give a wee quick. So this is the brush mechanism for the earth clamp, so the earth clamp doesn't turn with the workpiece. It rather stays fixed to the table or fixed to the machine. So basically I put the earth clamp onto there. There's a wee insulating board also at the back of this. To create any problems or happening, so it's just say, like if I put the air strap on here and the current goes through and damages the machine itself. So, or bad air too, obviously. So I'm going to point out here now before going any further. This machine used to have this, what would I call it, upright or welded at this point. So this fitting here, or this boss, was on here. So the reason I have moved it onto a new piece of box iron is to allow the weld torch sitting on centre of the workpiece, because of the contraption that I have made here. I will demo that when the weld torch is on. I'll give a wee quick sort of just walk through with the torch before I start welding. So that's really it. I don't want to talk about this unit too much. So before I start talking about mine, so we have this reset button. So this reset button really just starts this timer. So you could basically say on there. On would make more sense to me. This lock position is just to break the circuit for the connection going to the welder, so the welder doesn't start, but the machine, the rotary table, will go. This here is this direction, just so back and forward for this DC motor. We also can switch this to foot control. So what do we see? I can switch that down to foot control and use this pedal to turn the table. And also the output will be triggered going to the welder. So I can use this foot pedal for the welder too, but I don't use this. I just set it in the auto and walk away. Well, when I'm sampling these weld pieces here, I have it set up for my friend, so he doesn't need to stand with the machine. He comes back every 2 minutes and puts another workpiece on, and the welds are top notch. So what I'm going to do here now is give a demo of my workpiece. So, okay, so there's a lot to talk about in this video. It's quite interesting, right? So, whenever I bring this round first, 2 seconds here to tighten this up. So, well, when you're welding these pipes, you sort of want to be welding them at an angle. Take advantage of the table, the rotary table, rather than welding them on the side, so a nice strong weld. So, this head can be set at different heights. Basically by just slackening this off and wheeling it up and down. So everything past this head is, past this chrome part is my mechanism. So this mechanism works, right, by creating motion, moving this wee arm minimal amount. So it has to be minimal amount because you don't want the torch, well, the weld bead really any bigger than 10 mil. So we have a bicycle hub here, and this bicycle hub is turned down on the left. There's two nice neat roller bearings on each side. So the reason I use this is because you don't want no play in this at all, because when the torch is out here, the welding torch can be quite an overhang and you don't want play at all, so that the weave's a nice uniform shape and there's no play, so it doesn't jump about. So we have these ball connections here, plastic balls. This arm is basically just, what do we see here? A wiper arm off a Honda car that I have. So basically there's a ball pushes into this, and it pushes into the ball connection here. So these parts, as you can see here, are made on the lathe, so they are welded up and turned down the lathe with basically it's a bolt welded to the ball. These balls used to be welded pressed in with rivets onto the arms on the car, the wiper mechanism. So this is not a part of the mechanism. I have made this from scratch, really. Welded nuts onto it and left it adjustable. This wee control panel was also made a couple of days ago, just to finish it off. So basically I can go onto this unit here. We will demo it better in the garage when I get round to it. In the dark you'll see it better. So we have the wiper motor turning this this adapter unit. So you can see here in the end you have an arrow. So that arrow is to determine the weld width also. So this is a part here now, it can be quite tricky to understand. So this ball is offset from the centre of the shaft and the gearbox of the motor. If it wasn't and it was concentric with the shaft and the motor, it wouldn't give you any motion. So the reason I have an arrow here is because, what do we see if I turn this? I can't turn it because it's too tight. Can you see? No. So what do I see if I put it down that side here? The whole yak. Get a wee camera angle on. So inside you have 2 nuts, and the nut on the motor obviously stays tight all the time, permanently. The nut on this ball can be slackened, and this arm can be hit offset on the direction of the arrow, because the hole is slotted or elongated inside. This adjustable shaft never needs to be adjusted. It's just there, well, just say if you needed to tweak it in the future or whatever. Well, it's not really there for, it doesn't really serve a purpose, because at the minute the actual arm is moving perfect. This slotted area is where the adjustment can be made. But this is, let's say you wanted to modify the machine in the future and you wanted to have a longer shaft here or whatever, you can just add on a longer threaded bar. So a bicycle hub. So this is part of the pedal of a bike here. This here, I've turned it down the lathe and made this wee slot using 25mm bar and cut a slot in it. So the closer I bring this sort of ball or wee mechanism that I've made, this wee boss, if I slacken this and move that towards the shaft, I would have a wider weld width. The weave would be wider. So I'll demo that too, maybe, if I get round it. So taking this back up here now, if you ever want to bring the torch down lower, all I have to do is bring this cable through here a wee bit, and there you see, lift it out there. I probably should have it slacker, you know. You can see it was a bit tight there, so I can lower that away down to the bottom now if need be, which you never have it down that low really for the minute. So what I'm going to do now is I'm going to set this up on an angle, give a wee demo of this side. So this the weld torch can be adjusted with all these adjustments here. So basically I could screw the weld torch that would be clamped to this mechanism that I've made in closer to the workpiece. Now moving on to this side. So obviously the motion at this side, there's a shaft going through here, 2 bearings, and this part, it's actually, you'll see the pictures at the end of the video. It's actually a piece of 25mm bar turned down to lathe at this side and then cut out with a grinder at this side. And it's offset also too, so quite a bit of work on this, footery work. So this is a part of a bicycle seat. So the bicycle seat's there for me to adjust the torch this way, rotational, on maybe, what do you see? So I can adjust the torch on one axis here, then this axis, and then I can bring the torch closer. So what do we see? We have 1 axis, 2 axis, and actually 3, because I can move it on out here. So it's actually, the bike seat worked out very well. So these wee notches that you have on the bike seat can hold, so basically it's just the mechanism out of the bike seat. And I've taken advantage of it and used it. It's just out of the scrap. So this is a G-clamp, a 2-inch G-clamp, just welded to the parts that I've made. So I can clamp the torch of the MIG torch or TIG torch even, whatever. But for the demonstration purposes today, I will be welding with the MIG. So I think I've talked about everything there. I know I've covered a lot fast. So this power supply box is made up. So basically it's 230 in and 14 volts out. And 14 volts then can be seen on this wee monitor display. So I can screw this down to decrease, slow down the speed or generation from point A to point B of the weld width. I'll demo that too in the shade now in a minute. So what I'm going to do now is take it in the shade, but first things first before we go further. So you can see here this blue frame. So everything blue and everything orange is my mechanism that's made up, and the stainless steel enclosure. So we're going to take it in the shade now and start welding with it. Give a wee introduction of it working, or a wee walk through. So I'll turn it on here now. So you can hear the motor going there, right? And you can see this moving up and down, you can see there's no play at all because the bicycle hub's good and tight. So I'm going to take it on the shade now, put the torch on it and give a wee demo on it before I move on to welding. So I hope you enjoy, everyone. Okay everyone, so what we're going to do here now is we're going to set the MIG torch on the mechanism that I have made. Just going to show here what welder I'm using. So the welder I will be using is a Jasic inverter, MIG welder. So very smooth compared to the transformer type welder. So the welder is maximum 252 amps. It's a Jasic 252. 250, 252, same thing. So I have, let me see here, a connection lead made up. So I've wired this lead to the control board of the welder. And basically what I do here is 2-pin plug, and I plug it straight into the back of the machine rotary table. So now when I trigger this machine by pushing reset, the green button, which I think it should say on or start, when you push this, it latches whatever the module on here, the PCB, and then a connection also comes out from a relay from this. So it is closed, and connection is made, so an input to the welder, output from the machine. So what we're going to do here now is demo the torch going on first before we go any further. So I'll put the camera on the stand here so you can see this torch. Well, it's like a Euro type torch. So what do you see? I should point out here I've got this bit of glass, so I'm going to try and demonstrate the welder and the welder and the mechanism in action. So we're going to do just a straight line weld string. And then I'm going to do sort of weaving. So weaving motion. So I'll set this camera on the stand here for the meantime. Get it on here. So what we're going to do now is place the torch on. Let me see if I get her set up. So what you want here to do for this machine is keep the lance, what do you see, no bends in it, nice as straight as possible. So what I'm doing here now is placing the torch into my clamp. So this clamp's designed for multiple, well obviously many TIG torches and MIG torches, any torches for welding really. Obviously not for arc stick welding because you have to sort of scratch start. So here now we are, I'll bring the camera up. You can see how well the clamp takes hold of the torch itself, quite rigid. So the reason it is so, well, it's because of the design. So it's not two plates cramping on the torch, it's two, I'm going to open this out again to see. Never demoed this outside in the introduction, so what do we see? So you can see there that I have created two they're large radiuses to match a torch of a MIG or TIG. Basically, so it has good well, it holds it well and it's not going to flap about when the mechanism's doing its task. So what do we see here now? Get this back in and we're going to start with this demo. I should point out here, as I've stated, this welding glass will be on the face of the camera. I am also going to try and not, well, I want to keep the sparks away from the camera, so I'm going to have to cover it with a lot of dry rags. I could use wet rags, but I don't want the lens to steam up there, so tightening the TIG torch, or sorry, the MIG torch, my head's away a bit, and the position. And the next step then after that is, I want to see if this camera's on the right position here. The next step after that then will be, what do you see? Setting the rotary table, the angle. So what I want when I'm welding these rings is to be welding down on it rather than welding it on flat. So you're sort of welding into the V, like so. So we're going to start in a wee minute, but setting it up here first. So you can see here now that the torch is in a wee angle away from the workpiece. So what I want to be doing with my mechanism here is slackening the 13mm nuts that are at this point, or this axis, and basically I turn the torch. This is a bicycle seat mechanism, so it works so well. And then I will use the machine's little screw itself to bring the torch out. So there, looks good there, but what I want to do is I want to make sure I'm not too tight to this plate. So I can also, I need a 14mm spanner for this. What I can do at the minute is just move it, yeah, like so, and then tighten it up later. So you can see here now that the wire is more or less pointed towards the V. So what I'm going to do here now is give final setup, and then I'm going to start welding. And I'm going to put this glass in front of the camera, as I say, so I'm going to need to put double-sided tape around here. That was a full piece, but I actually fell on the ground and my one broke. So I'm lucky I've still got a big bit here. I'll bring the camera up close, I will cover the camera in rags, and yeah, take it from there. So hope you enjoy. Okay, so before I start welding here, right, what I have done is made this wee arrow, right, wee pointer even. So what do we see here? Just look at this torch sitting right there. So make sure that I'm sort of even between the, well, where the two edges meet, or where the edge of the pipe tube meets the plate, the flange. So what I can do here is I can screw this out, like so. Okay, so what I want to do here now, right, is I'm going to turn the torch on just to give it a wee demo of the motion before I go any further. And then at the end of it then I'm going to show how I can adjust the width of the weld bead. So if I turn this on now, I forgot here, I never demoed the panel. So, okay, so the panel here, right, I can, what do you call it, set this voltage at the top. So I'm at the 12 volts, right? So basically, I can set this. So I'm going to go across to millivolts and adjust it and that. So if I can now turn this on, so you can see here now, look, how well the pattern, well, the width of the bead is going to be. So what I want to do is I want to center that action to sort of where the edge, as I say, meets the plate. So it looks alright there now. So if I start welding this and I notice that the weld's too much up the pipe or too far down the V, all I do is adjust this knob here back and forward. So at the minute I can see it's a wee bit off, so it looks alright there now. So you can see there how well the mechanism works, with even the torch on it itself. I'll go from this end to get a look at it. So I am going to demo this when the actual, when it's welding through the dark glass on the camera. But before that I just want to give a wee quick final demos of the voltage controller and stuff. So I can alter this voltage. What do we see here? If I remember how to use this. So I can alter it by the volts. So I can turn the duration between the weave or the bead before it meets point A and point B. You can see it there, it's too slow at the minute. So if I turn it up to 6, so now it's at 6 volts. Okay. So you can see here that it's nice and slow between point A and point B. So as I say again before I go further, point A and B can be increased by bringing this wee mechanism in here, this wee arm, the ball joint, in closer to the centre point of the shaft using the slot. So basically all I do here is slacken this 13mm nut. So just to demo it now, speeding up when I turn this control knob, so you'll probably hear it. You hear it ramping up there. So that's like a wee pulse width modulation controller. So there now we have it going, well, probably about 80% of its pace. When I'm welding with this MIG, well, I've never used this one before. So at the minute there, sorry I wasn't on video. So at the minute, if I set this, obviously I'm only going to get the maximum power of the power supply that's giving power through the motor, or to this wee unit. So what do I see here? I'm going to go into millivolts and turn it up by millivolts. So I've got 13.6. What do we see? 13.5 volts there now. The top, see the top of the screen? That's the volts that's going out to the motor. That's the current the motor's pulling. So basically, if I hold the TIG torch, you might see the current rise up a bit. There you go. So if I hold it, it'll rise up. So basically, I'm putting struggle on the motor. Or if I even hold this back a bit, you'll see it pick up. If I pull, there it is. So the bottom one's the wattage that the motor's consuming. So what I'm going to do now, right, is I'm going to do the weld, and that's it. Hopefully that'll be the end of the video. So going to put the dark glass on the camera here now and take it from there. So I'll turn this off first. So this is going to be the sample piece, and then I'm going to, when the welder's set up, I'm going to do the final welds. One with no mechanism, and one with the mechanism that I have designed. But first things first, I'm going to do this. So before I start welding, I need to make sure that the turntable does a full revolution. So I'm going to put this wee arrow on the piece of pipe and set the TIG torch, or sorry, the MIG torch. I keep getting mixed up because obviously I do a lot of TIG work. So what I'm going to do here now is set this up once and for all. I'm going to see if it's going to hit there. Just make sure that the torch is in the right place. So you can see I'm too low there. Too far away there to the point too. So you want to be coming closer. Make sure the gas covers the weld bead. So down, that's there now. Okay, so what I'm going to do now, right, is I'm going to set this wee arrow on it to make sure I do the full revolution. Oh, that one's done. I'm going to get a new bit of tape here. Turn this off. Okay, so we have this set now. So it's taken 1 minute and 56 seconds for it to turn and do a full revolution at the speed rate that I want to do this weld, or to lay this weld. So what I'm going to do now is start the platform just to demo this. Here we go. Turn the mechanism that I have designed on, just so this is exactly the position, the welding torch, the speed rate that the turntable will be turning, and also well, that's everything that's required to lay this weld. So I might need to bring the torch closer using the mechanism, or sorry, the machine, the wee screw handle over and under. I also might need to adjust the height, but for now we're just going to demo this stopping back at the wee blue arrow that I've created. So I might need to slow down the mechanism there, the wave pattern, the speed of it from A to B, this side to this side, this side to this side, just like creating wee triangles or like a ladder weave. So hopefully it should be a nice, neat weld. I might need to alter the current on the welder and the wire when the welder's going. So you might hear a change being such as limited wires. You might hear me fine tuning the welder when this is welding. So here's the arrow approaching. It is now at 1 minute 44. There is 10 seconds left. So hopefully we end up at the arrow, if not a wee bit past it. So there we go. So that is exactly, and then I can stop my mechanism that I designed for the weave. So that's it. So we're going to start here now, and I hope you enjoy it. I hope it works out well. I'll do this run. Then we'll work on to the other flange that has, or sorry, the other piece there that has the 2 flanges on it. So I'm going to do a weld, a stringer. So basically just a straight line with no weave. No pattern at all, just a straight line, and then I'm going to, so basically I'll be just directing the torch towards this V, and then I will do the final weld with the welder adjusted. So this one here at the minute is only for sampling and setting up the welder. So you will hear me fine tuning the welder. You hear a note change. So here we go. Okay, so we are ready to weld here now. So I have to make sure I have the earth clamp or all the preliminary steps done. So earth clamp connected. We have the signal coming out of, what do you say? The signal going to the welder from the control box. So basically this starts my welder inverter up, is connected up. We have to make sure that the torch is in the right place, the right angle, and we have to make sure that the time is right on the rotary table and the speed. So first things first now, before I go any further here, I have to make sure that this vise is tight, because when you apply heat to this ring it's going to expand, and when it expands it's going to fall out of the vise. It gets slack even. So we are ready to rock now. So what I'm going to do is turn on my motion mechanism for the weaving. I'm going to zoom the camera in to the right spot, and hopefully it stays in focus. It's not in focus there at the minute at all. This is my eyes. Okay, so not bad there, a wee bit too far away, yeah. So that's it. So next step now is starting the welder. So I have the gas set at roughly 9 litres a minute. We are indoors, so all's good. So basically now when I plug or switch the welder on, everything's ready to rock. So there we go. I'm going to put a welding mask on here too to keep an eye on for the meantime. So this is only a test piece, so it mightn't turn out very well, but we'll give it a go anyway. So you might hear me altering the welder as it welds. The wire might run low or it might be too slow, the feed rate, so I will be adjusting the welder to account for that. So what I'm going to do here now is place this shade 10 on the camera, just make sure it's clean first. Okay. So we're going to place this on the camera for this procedure. So there we go. Hopefully you will see it now when I start. So as soon as I start the button here now on this actual control panel, not the welder will start itself. Everything should start welding. So here we go, mask down. So I might be running over to the welder here to adjust this straight away. We might also be adjusting where the torch sits on this flange. So here we go. Okay, when I take the screen off. Oh. So I really hope there's the weld. I really hope that you were able to see that on the screen. I'll not be able to know until I play it back here. So when I take the camera off and get a wee close up. So as you can see, the welds are pretty perfect. Sorry, the weld. Nice wide bead. It is really precise. I actually used a transformer welder with this unit, and the weld's not the same quality. So what I'm going to do here now is I'm going to put the other part piece on and do a final weld. I'm going to do a stringer without my mechanism. You see that the weld will sit sort of in a ball shape. That weld there is sitting nice and flat and neat and looks perfect. Strong too. So it took 2 minutes, 1 minute 56 seconds, 1 minute 54 to complete. So we'll do the other one now, and I hope you enjoyed. I hope you could see that too through this welding glass. I have to check that now. Yeah, brilliant. Okay, so that worked better than I thought it would have for an initial test. So the reason I have a torch off here at the minute is just to clean this right. So this is the final test weld. So what we're going to do this time is we're going to weld it without, basically just lay a stringer right around it, just to show the difference of the weld bead itself. So placing the torch into the mechanism that I have created here. So this is just going to be held in a fixed position this time. And then I will do a final weave at the top flange, this side. And I will increase the distance of the weld bead using my mechanism, the adjustment at the back. So now set the torch again, ready for the final weld. You could see a bit there in the camera, but you know, you could see my mechanism working side to side. You're obviously not going to see the weld as clear as you would your TIG welding through the shade glass, but it's better than nothing, isn't it, for this demonstration. So we are going to do the same thing again now, but we are not using my mechanism. We are going to keep it off. We are just going to start the welder, and hopefully it finishes at 360 degrees. So here we go, just making sure it's in the right position. So what I'm going to do here is put the shade glass on again. I don't want the welding getting near the camera and the inside, because there's a mechanical motion softener thing in this camera. Don't know the proper term for it. So actually, hold on a minute, I'm going to have to zoom in here first. So we'll zoom in. This time you'll see the torch not moving. So it's not bad at that, you know. So here we go. Again. So we're going to start welding again. So ready to rock. All I need to do is push the button here on the control box of the rotary table. So you might see, you won't see me, but you might see the torch getting closer to the workpiece or further away. So this time my machine won't be turned on. It'll just be laying a weld, a stringer weld right round it in a straight line. So here we go. Hopefully this works out. Okay, so that's it finished. But I'll take this shield off. Please get a look at the weld. So the weld's quite neat here, as you can see too. But the width of it is not as wide as the weave. You can also see that the weld is sitting at a higher. So the wire's stuck here. Hold on. So the weld is sitting at a higher, sort of like a bevel in the middle. It's not as flat as it is with the mechanism, the weaving mechanism, but it is quite neat too. So that's inverter technology for you too. So you can see how smooth the welder is there. So what I'm going to do, the welder, so what I'm going to do now, right, is going to be a final weld, but I'm going to increase the width of the weave by using this wee slot. So basically I'm going to take the weld bead out to approximately 10 mil. So the torch will be moving this here at the torch out at this distance will be moving 10 mil instead of 6, just to see the difference it has on the weld itself. So I probably could set the wire burn back here at this point. I'll do that maybe in the next run. So we're going to start here now again and do the final run. Okay, so you can see here now at my mechanism I have moved this little control arm and more closer to the center of the shaft. So in turn this increases the distance between the weave A and B from the start to stop, start to stop, start to stop. So I'm going to demonstrate this here now. So now we have a weave of about 10 mil, so increased from about 5. So if I want to make this bigger again, all I do is go up to this top linkage here and move the shaft, or sorry, this little adapter, this little ball further away from the center of the motor shaft gearbox. So I'm going to place this camera in now for the final time. Hopefully you get nice video demonstration of this now, zoomed in. Welder set, gas is on, everything's ready to rock for the final time. We have the two units, the welder and the system connected up. Next thing now is zooming in to this weld area. So I'm going to try and get this in shot as best as possible. So at the minute the torch is kind of facing the other direction. So I think it's okay at that. You might be able to see there the welding leg. So if the camera was a wee bit lower here, hold on till we see. I might put it down on the floor actually. Actually I'll do that, you know. Zoom out a wee bit in the meantime. So if I'm getting it angled, what do we see here? Maybe at this angle will be better. So I'll set her up on the floor instead here. There we go. Hopefully this is going to work for the final time. This is the last piece I've got, so it's going to have to work. Okay, I'm going to zoom in here at this point now instead. So you can see here I'm sort of going up the pipe a wee bit with this weld, but I'm still on the flange. And we're sitting in a V, sort of like this, with respect to the earth. So we're sitting nice and with a torch pointing straight, sort of perpendicular to the ground, if that makes sense. So the screen on for the final time, the welder's set and ready to go. 1 minute 55 seconds increased. I've actually turned on burn back this time to keep the wire from sticking. Why don't we just make sure this is in view here before I put that lens on. So there we go. So that's it. Final time. So we're going to start welding here now. I'll put my mask on. Gas on. Okay, hit button on machine. Air clamp on, ready to rock. Nice wave, nice and wide, much wider than the first one. Okay, so we're finished. Oh, that's us finished. So the weld is beautiful. Just enough gas, not enough gas. What do you think? I think it looks quite good. So we have the machine turned off. So what I'm going to do here now is going to take these workpieces outside, compare them a little bit, and then wrap this video up. Okay everyone, so we have the final pieces here now. So if you look at this weld closely, you can see it looks quite wide and neat between the flange plate and the pipe. So this one's still hot. So this is the one that I increased the width of the weld. So you can see that I have it too wide. I'm sort of over the edges here a wee bit, but the weld looks quite neat and uniform the whole way around. This is the finishing point. I could set the burn back better at this point. I just never, just for the sampling process, I haven't done that. So the wire tends to stick at the end. We have a nice neat weld the whole way around. So this is the one, the widest weld. So if you look at the difference between these two, you can see that this one's over the edge a little bit, and you can see that this one's not. So the first setting, manual setting, was better than the second, making the weld too wide. So if I flip this over the body, oh, it's hot. You can see that this weld's sort of like a stringer, so it's straight. You can see that it is not coming over the edge. It welded quite well for not being put through my mechanism. Just a torch in the one place. However, I do notice the difference between the inverter and the transformer welder. I should have probably demoed that for this video, but I didn't. The transformer bead would be much, well, it wouldn't be as neat as this. The inverter is just much smoother welder. Like if you look at the top of that weld, it is just pure flat, pure smooth even. So here you have the wide. You can see the difference there. So I could slow the time between A and B between the weave, but I never got around to doing that. But I can alter the voltage as I have shown in the video at the earlier stage. So that's it. All wrapped up. I hope you enjoyed the little demonstration. Really turned out well, the wee project. I hope my friend enjoys it and uses it for a long time on his little well, projects itself. So thank you for watching everyone, and goodbye. Okay everyone, so we're going to start here now with additional design, and first things first, I added these video clips to show the smoke and the sparks and the rotational table going flat out, no control, and smoke appearing from the pins there at the back of the plugs. So this in turn shorted out the circuit board that had to be repaired, the PCB control board. So this is the wiper arms where it all started in the beginning. So this is out of a Honda Accord, and obviously good quality Japanese motors, and so it's Denso motor. Good robust arms, not the cheap plastic stuff that you would get in the French cars and stuff. So this is the adapter that I started to make first. So this is used to create the oscillating motion. So this adapter actually turned out to be no good. It was too coarse, way too coarse. So the TIG torch, or sorry, the MIG torch was moving, I think it was about 1 inch or maybe more, 50mm at the end. So I had to come up with a better idea. So this is the bracket for the motor, the mounts, and also the little connections that were turned down on the lathe, the ball connections. So this is a bolt welded to the actual ball of the car, the mechanism. and it was then turned down on the lathe after it was welded up fully. First things first, there's a little video clip coming up here of turning down this part here seen. So as I stated, this part in the chuck of the lathe here is basically the lever of the, what do you call it, the wiper motor. So I have cut it and I have added a bit of channel onto it, and I have shaped it and welded it and grinded it. At this point I'm just cleaning the face for the ball to be screwed to it, to be attached to it. So in the middle there you have an elongated hole, oval hole. So this elongated hole was, well, it was very difficult, this adapter, to sort of, it's quite hard to explain here, to get a minimal amount of movement on the welding torch. So at this point, when it was all constructed together, I could only get a minimal movement of 50 mil. So I had to change the design completely. The images coming up here will show how I fixed the problem. That's me with a mask on there. So this is the part complete. It was placed on the wiper motor, and along with the bracket that was seen in the images previous there. So you can see it has a nice milled face, turned down on the lathe. So next thing now was working with these little balls. So these photos are very detailed, just goes on to the design and how I came up with it and what way I went about it. So at this point I was just playing about with it and seeing how it was going to work out. So next step now was finishing off these linkages. So this is completely welded, obviously at a high current, so you can see it glowing red there. So this is an M8 bolt, 1.25 pitch threads. So this is then placed into the chuck of the lathe and turned down just for tidiness. And also I shaped this actually into a sort of a nut, effect, so I can put a spanner on it, like a nut feature even. So just two slotted faces. So first things first, I have to turn this down to a nice diameter. I think it was about 13 mil or 14 mil. Near enough. Doesn't have to be accurate, you know. So the images now appearing are going to be the, well, final outcome from the lathe, from it being turned down. And then I add the slots, basically with a grinder, and then I'm moving on using a file. So just different angles of this here to show the level of detail I went to. So it looks well. Okay, so the image is now appearing as me leaving the little flange or little slotted faces, you could say, for the spanner. So basically, so I can tighten these little adapters or these little connections, ball connections, onto the brackets or onto the adapter that I will be creating for the motor. This will be up here now, the new type adapter. So this one had to be more precise. So seen here is the whole thing sort of coming together, but just keeping in mind that I don't use the adapter that's on the motor at the minute, as it's too coarse. So the next step then after that was building the linkages. So the linkages, I built them to be adjustable. And you can see at this stage that the linkages is much longer than they are at the video, or in the video clips. That's because I have altered them at the end. So there you can see they're much maybe shorter at that time. That threaded bar it's obviously one direction. So if I want to extend, or you know, I have to clip it off one of the balls at either end. It's not left hand thread, right hand thread at one end of it, if you know what I mean. So this is the little connections, female parts, whatever you want to call it, coming together. So another ball with bolt welded onto it was required for that motion. So it was also important here not to damage the balls, because if I damaged the ball, a steel ball, it would eat into the plastic fitting on the arms, or the nylon fitting. So this is the old fixing bracket that the welding torch was attached to the rotary table. So I had to make a new clamp design that will be coming in the images at the end of this section. So here we are starting to make the sort of bearing, bushing, sort of pivoting point that the mechanism will control the torch through. Okay, so at this stage I didn't know how this bearing or bushing assembly was going to perform. I actually thought it was going to be much tighter, higher tolerance than it was, but when it was welded to this bracket plate in the background that you can see me cutting out there with a grinder, it underperformed and the play was too significant, it was too excessive. So what I done is I needed to get some sort of a bearing, high tolerance bearing unit that could be put in or placed in, rather than using that made up bushing with the two washers in the shaft. So let's follow, well, coming up here now in this section using the bike parts. So at this stage I am making the linkage for the motion, so the adjustable linkage that will control the width of the weld bead. So this is just done using the grinder and the Dremel, and we're basically drilling 2 or 3 holes and then sort of eating it out, if you like. So here is another one of these ball linkages that needed to be welded up and grinded and then turned down the lathe again. So it was a lot of work, a lot of footy work here in getting this working, but it came together nice in the end up. So this is the second ball mechanism or fitting that was required. Again, it was turned down to approximately a diameter of 13 or 14 mil. I'm just cleaning the back face here at this point. So what is this part? Let me see if I can remember. So okay, so this is a new adapter. So the square adapter you seen at the start was not used. This is a new adapter that I have turned down, and basically I've cleaned the faces and tried to get everything more centralized so that I could obtain minimal movement at the welding head torch. So to do this, everything's turned down and set into sort of nice grooves into both flanges faces here. So I have turned everything down the lathe and pressed everything together and clamped everything together when I was welding it, to ensure that the 2 faces were concentric and the 2 holes were near concentric as possible to obtain minimal movement off the welding torch head. So at this point I am, after it was turned down, I had to remove the 2 nuts or 2 bolts from the inside that were held in the chuck of the lathe. Also, this was also a sort of like a window hole that the nuts for the motor could be tightened, and the nuts for that ball linkage also could be tightened. So here I am cleaning it with the carbide burr on the Dremel pneumatic tool. So at this point, this linkage, well, it was welded to, this is the initial design here I'm showing. I think there might be a video demonstration of it working here coming up, but it was too coarse, way too coarse. So I had to revert to the bicycle bearing pedal housing. So here we go, you can see the vice grips is moving, well, very good actually. So that's the new adapter that I have on it. But see, if I was to grab them vice grips there, I would be able to feel play when it was running. So this bicycle hub, old bicycle was used. So basically what I've done here is I have cut off the excess material, the tubes and any wee bits of flat steel you can see there. I have turned it down on the lathe as best as I can because there was not much to work off, considering the sort of faces were clattered in welds and plates, and so I had to clean one end and then turn it around, and near enough, didn't have to be perfect. So what do you see what this point is? So this part, okay, so this is a part of a pedal that was cut and chopped and welded up again, turned down in the lathe. So this was used for the linkages, and I basically turned it down first. So this had a wee square, sort of like a square female hole that slid onto the shaft of the bicycle hub. So you can see there the finish that I achieved. So it's better than nothing, but the tool in the lathe became quite blunt at this stage. But there's the end of the bicycle, the scraps. So this is the new bicycle hub, now done away with the bushing, the 25mm pin. So this weave can be narrowed down by moving this linkage out to here. The display of the weld, the width of the weld bead. So the bicycle hub, little linkages, little adapter, all made up. Okay, so we don't have much to talk about now. More just going over the things that you've seen there. So this is the old welding sort of bracket that held the torch. So I had to hit the pin, split pin, roll pin out there, and make a new sort of shaft that can be pressed into that mount or that linear screw bar that can be adjusted on the rotary table. So I'm turning down the shaft at this stage to fit that linear sort of connection on the rotary table. So there we go now. So that male shaft can now slide into the female part of the rotary table, and a whole board in it for this roll pin or split pin. So this is the bicycle seat that I took advantage of. So you can see here it is very adaptable and flexible. Well, obviously I can slacken that nut and everything will move on 3 axes. So I needed to make a shaft for the center where the seat used to, or the shaft of the seat used to go down into the bike. Okay, so at this stage I am creating a flange that can be fixed to the hub where the pedals used to bolt on to the bike. So basically just cutting down the 2 sides of the shaft and shaping it into a nice lug or flange. So I can bore an 8mm hole in it. So this is it done, and you can see a counter bore there in the back of it too, just to allow it to slide on nice and neat to the shaft here at this point. So I also made a little well, so this little part of the pedal is to keep it from turning, but I later removed that piece to allow more flexibility for the torch to turn on that axis too, rather than keeping it fixed. So basically you just tighten the nut to hold that lug that I have prefabricated. Okay, so moving on now to the other axis of the seat bracket, or the torch mounting point. So this was to allow the torch to be slid back and forward into the workpiece if it was required. So say if you want to extend it the way out to weld 12-inch pipe or something like that, well, or even extend it in to weld 1-inch pipe. So here at this point we are making the clamp for the welding torch. Then it will be welded to this, well, these sliding bars that can be slid in and out. So basically this can be achieved just by slackening the M8 nuts, either top or bottom. So that welding torch can be turned on the axis parallel to the bolt, or it can be turned on the axis sort of 90 degrees to that, and it can also be slid, the torch can be slid back in and forward. So there's a lot of movement here which is required for the setting up of the welding torch, the angle of the welding torch, the distance from the workpiece. So at this point here I am creating two little radius, well, nice curves, sheet metal that can be attached to the weld clamp that will form the weld clamp. So basically one of these will be tacked to the L bracket there that can be seen on the adjustable bars. So this is basically just spot welded to the plate that currently exists. 3 holes, 3 spot welds, and that's really it. So it's quite simple but effective. So this little radius curve can hold the weld torch well better than having the weld torch sitting flat against a flat bit of steel. So you can see here now it is in position, nearly ready to be welded. So at this point I have one spot weld and completed, ready for the next two, and you can see the nice curve there that the weld torch will sit in. So the adjustable part of this will be was done using a G-clamp, 2-inch G-clamp cut in half. This little plate that is identical to the other one is actually just welded to the part of the G-clamp that swivels. So the point that touches usually the workpiece. So the screw then can be turned in and out without interfering or digging into the weld torch itself. Obviously, as all the weld torches are mostly made out of a soft plastic material. So this is a clamp mechanism finished, worked quite well, brilliant compared to the one that came off the machine. Held the torch much better than the V, aluminium cast V that they had formed. So common sense how much pressure that you would tighten onto the welding torch. Didn't have to be that tight, but tight enough so it didn't move when the oscillating motion was in action. So this is the first time I tried a friend's welding torch in my gadget or my mechanism, the mount point. At the end up you can see here that you will see that I painted all them parts. So this is the stainless enclosure. The square there is for the pulse width modulation power regulator, and the round part there is the part that will slide over the motor, the armature housing, so it can be attached or screwed to the motor. So quite simple but quite neat. So this is mounted up on the oscillating sort of mechanism rather than mounting it down on the rotary table itself. Basically because the closer we keep that wee modulation unit to the motor, the better, less wiring and stuff. So here's the housing, the magnetic housing of the motor. So just getting the shape and the holes and the mount points and seeing where everything sits. So this is finished and ready to be mounted to the motor at this point. Lots of photos just to show the detail on the level of work. So this is me wiring it at this point. The wires going to the motor, and at this point there's no backing on this to protect the little module. Just say if you were to spray oil, or even I don't know, if you spray a little cooling liquid up towards them balls, you don't want to get it on the circuit board for the motor controls, otherwise you would destroy it or blow it up. So at this point we are finishing off the welding of the bottom, or sorry, one of the linkages that drives the mechanism. So it's important this wee linkage is tight and doesn't move, otherwise they play at the head of the welding torch. So here we can see I'm cleaning all the parts using chemicals, thinners before painting, reassembling the bearings into the housing and finishing off by painting. or spraying it. So I'm spraying each component. So primered at this stage, all turned out quite well. Power supply, how it was mounted in the box at this stage, and the final images closing off this whole video of the, well, painted parts, components. So the paint used here is just a tractor paint, 2-pack paint, 2K, orange and blue obviously. You can also see the modified part there of the rotary table itself. This is the back end, the last part that was made for the oscillating system or oscillating device. So basically this is just to protect, as I've mentioned there, oils or waters or anything hitting the little control board. So this was done out of stainless too. And I didn't use the TIG welder to weld this together, I just spotted it with the MIG in the back. It couldn't be seen. So here, 4 spots, all finished, 4 tacks, clamped together with the vice grips, and then there was a nice side panel put on the enclosure itself. Wasn't fully welded right round, again it was only tacked with the MIG in the inside. Keep things simple, less time required. So final images here closing off this video are just showing it all assembled together, as was seen in the video clips, the demonstrations. So this is final images of the device, basically without the rotary table, so everything here was well made. Painted, all finished, looking pretty, works so well too. Okay everyone, so that's it all finished. I hope you enjoyed. I hope you enjoyed it as much as I enjoyed making it and designing it. So more interesting projects will follow in the next coming months. I still have really detailed and interested projects to put up on my channel, but I just can't get around it. So I'm going to try and keep putting videos up every month at least, like I have been doing for the last couple of years. So thank you for watching everyone, and again, please come again and see more interesting projects. Thank you.